Hello friends, this is Vidhan. Welcome you to my channel. In my last video, we saw the derivation of output voltage formula for differential amplifier with open loop configuration. And I had the intention of doing the derivation for output formula for feedback also. But somehow it did not happen so. And therefore in this video, we will derive the output voltage formula for DA differential amplifier with feedback configuration. So here we have already drawn the circuit and this is the voltage output I have already written down, and we will derive this. And here you can see that since output is always gain times input, so this is the input. That means input is actually the difference of inputs. We know that differential amplifier always have two inputs and their difference is amplified. This is the work of the differential amplifier. So this difference of inputs, this will be amplified. That's okay. But look at the gain, R2 by R1 scaling factor. This gain is something that you have in your control. You can make the gain to be 5 or 10 or 15, whatever you want. Suppose you need to have the gain of 5, then what you need to do, you just put a resistance R2 here of value, suppose 25 k ohm, and put R1 equals to 5 k ohm. Then the gain is 25 k ohm by 5 k ohm equals to 5, and thus you have a control over the gain, and therefore you have a control over the output. And this is possible when you have used the feedback circuit. But for the same differential amplifier, if you don't use any feedback circuit, that means open loop, what is the output? We saw in last video, A times B plus minus B minus. Again, the difference of inputs is amplified. Similar to this, that's okay. But look at the gain now. It is huge. It is of the order of 10 to the 5 to 10 to the 6. And you cannot change it. It is already specified because you are not using the feedback circuit. So you have to work with this. And this is uncontrollable. It is huge, and therefore you have no control over the output, and that's why the circuits with open loop are not used in practical. And therefore this is the practical differential amplifier. Out of the two configurations, this is the practical configuration for differential amplifier. And we know this is the circuit where two voltages are there, and we take four resistances to make the circuit, and also we incorporate a set of conditions. The conditions are R1 equal to R3 and R2 equal to R4. That means we take two voltages, take four resistances, and do one more thing, that always take this resistance equal to this resistance, and always take this resistance equal to this resistance, and under this condition only, this is the output voltage, and this is what we will derive. So remember that whenever you have a differential amplifier circuit, you have this, you make this circuit, you take voltages for resistances, and also you take this resistance equal to this and this equal to this. This is the practical amplifier, differential amplifier. So we will derive this by using the principle of superposition. Now you can remember this is the same principle that we used to find out the voltage for open loop configuration also. That means the same principle of superposition is used to find out the output formula for feedback for open loop configuration for differential amplifier. And we know that there are three steps that we have to go through under this principle. The first step is we will eliminate this voltage, and only this voltage will be available to the negative terminal, and under this condition we will find the output. The second step is we will eliminate this voltage, and this voltage will be available to the positive terminal, and under this condition we will find the output. And the third step will be we will add those two outputs in the first and in the second, and that addition is our final output voltage. So let's do that. So at first I will make this V plus equal to 0. In reality these voltages are always there, they are not going to be 0, but this is the way the principle works. This is the way we find out the output voltage. This is the principle actually. So we make first this is 0, but V minus is present, it's present. So let us draw the circuit. So I have eliminated the voltage. You can see there is no voltage now. all the voltages with respect to ground, R1, R2, R3 and R4. This is V minus. Now what circuit this is? Obviously this is inverting amplifier with a feedback, because there is only one voltage in this circuit, this voltage, and that is available to the negative terminal. So this is inverting amplifier, and there is a feedback, so it is inverting amplifier with feedback. That means using this condition our circuit has changed into this. Now one more thing, that here the voltage is obviously 0 and 0, and in this circuitry to the positive terminal there is no other voltage. So since there is no other voltage available, so at all the points the voltages are 0. That means writing down these resistances is insignificant now. So we may do one more thing. Since these resistances are insignificant, so I can directly show the ground. That's okay. And in this way I can recognize our circuit in a better way. Now we can see that it is really the inverting amplifier with feedback. Then what is the output? We need to find the output. So what is the output? The output is for inverting amplifier minus feedback resistance, that means R2 by R1, input V input, and V input is what? In this case it is minus R2 by R1, and V input is V minus here. V minus, you don't need to be confused with this minus. This is just the symbol that this voltage is available to the negative terminal. That's it. Otherwise I can write V1, V2 or V prime, V double prime, etc. It's no problem. So this is the output. So our first step is done under the principle of superposition. Now the second step is that we will eliminate this voltage. We will make this 0 and this will be available. That means V dash, V minus is 0 now, and V plus is present, is there. Now under this condition, now let's draw the circuit. This is R1, R2, R3, R4, and this is V plus available. Now what circuit this is? This circuit now change into this under the second condition of superposition principle, and this is non-inverter circuit with feedback. The reason is there is only a single voltage supply V plus, and that is available to the positive terminal. So it is non-inverter circuit, non-inverter amplifier, and since there is a feedback, so it is with feedback. Now one thing you have to notice, that in this case when I made this voltage 0, then these resistances became insignificant and we just erased them because they are insignificant. At all the points the voltage is same to be 0. But now I have eliminated this voltage, the V minus, but now these resistances are not insignificant. I have to write down these resistances. They are not insignificant because here there was no other voltage supply. I eliminated this V plus, but there was no other voltage supply to these resistances, and that is why these were insignificant. But when I eliminate this V minus, Still there is a voltage supply in this circuitry. The voltage is from the output. We know that what is feedback? Whatever the output that we get, a fraction of that output is fed back to this circuit. That means there is still voltage in this circuit. So even if I eliminate this voltage, there is voltage. And that is why I cannot now eliminate these resistances. They will be there. So in this circuit, even if I eliminated this voltage, these resistances are still there. This is important. So I told this is the voltage, sorry, this is non-inverter circuit with feedback. Now what is the output formula? Output formula we know 1 plus feedback resistance, that means R2 by R1 into V input, this. So let us say V input. Now we have to find this V input. And what is the input? The input at this point. At this point. We have to find the input at this point. And we can easily see that this is a voltage divider circuit. These resistance R3 and R4 are in series. So what is the voltage at this point? We can find there is a voltage drop here. And we will find this voltage drop. And we will subtract this much drop from this given EMF V plus. And that subtracted amount will be the voltage at this point. Well, let me tell you, there is other way to find out the voltage at this point, and this is the trickier way. The point is, this is the last resistance R4. That means since this is the last resistance in the voltage divider circuit, so whatever is the voltage just before it must be completely dropped across this. We know that whatever is the voltage given to the voltage divider circuit will finally become zero. We know this. And the voltage at this point will be dropped by this. So there is a drop, and after the drop there will be some voltage, and whatever is the voltage here will be completely dropped by this. So always remember that in the voltage divider circuit, if you find the voltage just before the last resistor, if you need to find the voltage at this point and which is just before the last resistor, if you just find the voltage drop across this, it is enough. Because what is the voltage drop across R4? Whatever is the voltage just before it. Because it is the last resistor. Finally, whatever is the voltage here will be dropped completely to become zero. That means there are two ways I can find the voltage at this point. Either you find the voltage drop here and subtract this drop amount from V plus, and that is the amount available here. Or you may do one thing, that since this is the last resistor and we have to find the voltage just before the last resistor in the voltage divider circuit, so just find the voltage drop across the last resistor. And obviously the voltage drop amount must have been available at this point. So this is what we do. So we will find the voltage drop across this. So the voltage drop across the resistance R4 is equal to the voltage times the resistance R4 by equivalent resistance R3 plus R4. That means this much voltage is dropped by resistance R4, and since it is the last resistor, so this much voltage must have been available before this at this point. So this voltage is available at this point, and this voltage is finally dropped by this to make it zero. Okay, so this is the voltage at this point, and this is the voltage at this point also, and this is also the amount of voltage dropped by this. I think you understand it. Okay, so we will plug it input here. That means our input is now this voltage at this point. So let's see it, that V output is now 1 plus R2 by R1 into V input is now V plus into R4 by R3 plus R4. Now we will see the third step, and the third step is we will add the voltages. So let's name them. Let's name this is V dash, V naught dash, and this is V naught double dash. And the third step is adding two voltages, output voltages, V naught prime and V naught double prime. So in last step we add those two voltages in those two conditions. So at first we had this one minus R2 by R1 into V minus R2 by R1 into V minus plus V naught double prime, that means this voltage for the second condition, and this is 1 plus R2 by R1 into V plus into R4 by R3 plus R4. So this is the output formula, and you can see that this is a huge one. Now here we do one thing, a little maneuver. You will realize why we are doing this. Let's divide the numerator by R3 and denominator by R3. R3 by R3 plus R4 by R3. Here it cancel. So we have minus R2 by R1 P minus 1 plus R2 by R1 V plus R4 by R3 by 1 plus R4 by R3. So this is the output expression, and this is very huge expression, and we cannot afford to have this expression. That's why we must simplify it, and that is the reason that we use the condition that always in practical circuit R1 is equal to R3 and R2 is equals to R4 that I talked about. So this is the condition that we have to use now to get to our simplified solution. So here we have minus R2, using this, by R1 P minus plus 1 plus R2 by R1 into V plus into R4 by R3. Now R4 will be substituted by R2 and R3 will be substituted by R1. So this is R2 by R1 divided by 1 plus R4 by R3. Now again R4 by R2 and R3 substituted by R1. Now you can see that here this and this term is same, they cancel. So we have minus R2 by R1 V minus plus V plus R2 by R1. This is what we have now. Now if you take R2 by R1 as common, then we have V plus minus of V minus. This is the output voltage. So we have derived it. Now you can also show the output. Since R2 is again the feedback resistance, so we can write down RF by R1 into V plus minus V minus. So this is another way we can show the output formula, but we have derived it. So we use the principle of superposition, and under that we use the first condition that we made 0 and this is available, and we found the output. This is the output, and then we did this voltage to be 0 and this voltage is available, and under this condition we found out the output voltage, and then we added these two output voltages, and then we used the condition. Since this is the condition that must be used to simplify the output, otherwise the output expression will be very huge, and finally we get the output R2 by R1 V plus minus V minus. Thank you.